In this video, I'm going to go over some of the homework questions in homework section 2.3, number 19, 20, 21, 22. All four of these problems are actually very similar, okay? So as a matter of fact, if you actually look at these problems, 20, 21, 22 goes together, and the way how you do 20, 21, 22 come from number 19. So basically, number 19, let me take a picture of it real quick. Number 19 is basically having a function. Basically, we are having a function just like 20, 21, 22. And that function, f of x, is actually x squared minus 5x plus 9. It's actually right here. Okay. So, alright, so I'm going to do number 19, but I'm going to make it look like number 20. I hope you don't mind. Alright, let me copy this. So, the limit as delta is approaching to 0, okay, of this formula, okay, which we've seen this formula before back in I think it was back in homework section back in chapter 1. So basically what we do is we substitute, okay, this is f of x plus delta, so we substitute x plus delta of x for every x I see. So that will look like this x squared right here. Substitute for x plus delta of x, that will be x plus delta of x whole thing squared minus 5 times, okay, all the x will be replaced with x plus delta of x and plus 9. Okay, so let me just highlight this real quick. So all this first term in the formula is all this right here. Okay, then I'm going to minus my actual function here in a minute. So I'm going to write it out. So minus my function f of x. My function f of x is 3 terms. Substitute for one thing, so I put them in the parentheses. So what I'm going to do is simplify this expression, and then I will put in my delta of x just in a minute. So I'm going to give myself a little space because down here is all divided by delta of x. All right. You know, it's almost kind of like it doesn't make sense. If delta x is approaching 0, that means this delta x is approaching to 0, so that will actually become undefined because I'm actually having a 0 in the denominator. So that's not the way how it works. You got to simplify the expression up top before you can actually take a look at the limits as delta x approaching to 0. So this first term on the numerator expressions will give me x squared. Okay, perfect square binomial telling me that's x squared plus 2x times delta of x plus b squared. That will be delta x squared. Second term, negative 5 do with distribution, that's negative 5x minus 5 times delta of x, then we're still plus 9. Alright, now minus my f of x, this is basically like a negative 1 do a distribution to bring my 3 terms to the outside. So that'll be minus x squared plus 5x and minus 9. Okay, so all these guys is on the top. I'm still over delta of x in the formula. So things works out here because things will cancel. X squared minus x squared cancels out. 9 minus 9 cancels out. What else I have? 5x negative 5x cancels out. So what I end up with for my numerator is 2x delta of x plus delta x squared minus 5 delta of x, okay, whole thing over my delta of x. Okay, so when you did this particular example back in chapter 1, since every term on top has a delta x, so then we can factor out delta of x. That gave me 2x, okay, plus delta of x So this delta x squared, I'm taking one of them out, so one of them is left, minus 5. Whole thing over delta of the x. So as you can see, this delta of the x down here actually will cancel with the factor of delta x on top. So my expression now only have 2x. Okay, I'm going to put minus 5 in front of my positive delta x. Okay, move the negative 5 to the front. Plus delta of the x. Okay, so another thing I never wrote is actually the limit. Okay, so the word limit is all up front. So this problem basically at the very end is saying the limit, okay, of 2x minus 5 plus delta x as delta of the x approaching to 0. So once I see delta x approaching to 0, that means this term is approaching to 0. Okay, so that becomes 0 right here. Therefore, my answer is simply going to be 2x minus 5. And that's the answer. So in the following chapter, chapter 3, or your test 3 materials, when we're talking about taking a derivative, okay, of this function, x squared minus 5x plus 9, it's going through the limit process. Okay, so the answer will end up to be 2x minus 5. So student not quite, if you're not quite understanding the idea of a limit right now, okay, limit eventually becomes your derivative, okay, in the calculus class. All right, so for your other problems like 20, 21, 22, you just go through the same process. Okay, substitute x plus delta of the x for every x you see. Okay, it's just a lot of arithmetic here. You got to work it out. All right, and I hope that that helps explaining things a little bit.